Alright guys, مثل ما وعدتكم راح احل لكم مسألتين عن الانتجريشن حق الديستريبيوتد لود. خلينا نبدأ بالأولى. نبطل النوتس static C2. شنو عندنا؟ السؤال يقول لنا replace the loading by an equivalent force and couple moment acting at point O. يلا خلينا نسوي كروب هني عشان بس نخلي الصورة. السؤال نفسه ما نحتاجه وايد. كروب هني يلا خلينا نخلي الرسمة نفسها. Okay, هذه clearly is not a simple or composite shape. Clearly هذا integration. الخطوة الأولى طبعا نبدأ ونسوي لنا دلتا اريا. دائما مثل ما أنصحكم أنا خلوا الدلتا اريا شيء المستطيل يكون عمودي. دلتا اريا مالتنا راح تكون العرض بالارتفاع. الارتفاع مالنا يساوي W. المرة خلينا نختصر الموضوع. W هو 200 x أس نص. طبعا العرض راح يكون دلتا x. العرض هني دلتا اكس والارتفاع مثل ما مكتوب عندكم. alright, السؤال الأول أو المطلوب الأول يبي resultant force. عشان أطلع الدي resultant force لازم أسوي integration حق دلتا اريا. راح أمشي من هني لهني، يعني مسافة من 0 إلى 9 أمتار. From 0 to 9 meters. Alright, integration 0 to 9. Delta area is 200 x to the power of half. طبعا times delta x. يلا we have to integrate x. Let's integrate x. How's it gonna work with x? It's half, right? إذا كان عندنا, if we have a fraction, we take the one at the bottom and we add it to the top, right? X is gonna be x to the power of 3 over 2. And this is the 200. Divided by the same number that we have here. Divided by 3 over 2 اللي هو نص. From 0 to 9, now we substitute and we're going to end up with 200 times 9 to the power of 3 over 2 divided by 3 over 2. And in this case, we should get 200 times 9 to the power of 3 over 2 على 3 over 2. We should get 3,600 Newton, and of course this force is going to be going downwards. Alright, we get to the second part now. Where do we put this vector? I found the vector and I know it's 3,600, but what I'm looking for is what is the distance from here to here, which is x. For that, we have an equation. The equation says x equals to integral x delta area على integral of delta area. Now remember, we don't need to calculate integral of delta area. We already got it here. The one at the bottom is going to be easy for us. It's just going to be 3,600. Okay, yalla. X times delta area. Delta area is this. Times x. Essentially what's going to happen is x times x to the power of half. Okay, x الأولى is to the power of 1, so it's just like 2 over 2. If you multiply them, what do you get? You get to the power of 3 over 2. We're going to end up with 200 x to the power of 3 over 2 times delta area. Yeah, we integrate now. 200 times x. Again, remember, we add the base to the top. 2 plus 3 is going to be 5 divided by 2. طبعا هذا كله راح يكون divided by 5 over 2. يلا نسكر البراكت مالنا. شوية ضيجة هني, بس I think we can do it. من 0 إلى 9. Divide the whole thing by 3,600. Now all I need to do is come, and instead of x, I'm just gonna add 9. And I'm gonna put it in the calculator, so times 9. So, yeah, we no longer need this. Alas, we substituted the values. So again, it's gonna be 200 times 9 to the power of 5 over 2 divided by 5 over 2 divided by 3,600. And we get 5.4 meters. So this is the location of the force. So 5.4 meters. All right, so we put the location of the force, and the last thing he wants us to do is calculate the moment at 0. So that's going to be easy. Moment at 0 is going to be FR is 3,600 negative طبعا times the distance 5 times 4, sorry 5.4, and we should get negative 19440 Newton meter. طبعا it's negative, so it's going to be clockwise. So this is the first one. Let's see the second one. What do we have here? All right, this one is going to be a little bit annoying, but let's see what we can do. Replace the distributed loading with an equivalent resultant force and specify its location on the beam measured from point A. So the toughest part here is the equation itself, or the function of the curve, but the procedure should be the same. Let's see. We're going to have a delta area again. The width is delta x and the height is w. So delta area is going to be height w times delta x. So essentially it's going to be 1 over 6. Now I'm thinking about, should I open the brackets or not? Let's see how it goes. 1 over 6 times negative x squared negative 4x plus 60 طبعا الحين times delta x. I think we should open the brackets. Okay, so if we open the brackets, it's gonna look something like this. Negative x squared على 6 minus 4x على 6 plus 60 على 6. Okay, so 60 على 6 is gonna be 10. 2 over 6 is gonna be 4 over 6 is gonna be, we can say 2 over 3. 2 over 3, and the last one there is nothing we can do about it. Okay, FR is gonna be integral of delta area. Again, we start from 0 and we end at 6 meters. So integral from 0 to 6, and then we have طبعا هذا كله مضروب delta x. So we have bracket minus x squared على 6 minus 2x على 3 plus 10 times delta x. I think we can start integrating now. So it's going to equal to bracket x squared is going to be x cubed, so x cubed 3 ضرب 6 is going to be 18 minus we have 2x. The x is going to be squared now, so we're going to have over 2 times 3, which is going to be 6, plus 10, so 10 now is going to have an x, and we divide by 1 from 0 to 6. Alright, So essentially what we need to do is we're gonna take the whole thing now and just substitute with 6. So let's take the brackets off. Whenever you have an x, you add a 6 in its place. So times 6 squared, and here we have 6 cubed. Let's put it in the calculator. So the answer here is going to be 36. طبعا the force is in kilonewton, so this is going to be kilonewton. So this is delta area, or the integration of delta area. If I want to find x, then it shouldn't be that hard. X equals to integral of x times delta area على delta area integral. So again, we know delta area, and it's 36 kilonewton. And at the top, we have x times delta area. So essentially, this is our delta area. So I'm going to come and multiply the whole thing with x. And that's going to be it. So it's going to be bracket negative x cubed now over 6 minus 2x squared over 3 plus 10x times delta x. Okay, again it's going to be integral from 0 to a distance of 6. So let's integrate. The top is going to have a big bracket, so x cubed is now going to be x to the 4. 4 times 6 is 24 minus 2x cubed على 3 ب3 is 9 plus 10x now is going to be x squared على 2. It's like the bracket مالنا from 0 to 6. تحت طبعا we know is 36. Yeah, again we do the same thing, we just come and substitute. So equals to negative 6 to the 4 على 24 ناقص 2 times 6 cubed على 9 زائد 10 times 6 squared على 2. هذا كله divided by 36. So we should get we should get 2.1667. And that's it. So instead of all of this, I could write a force of 36 kilonewton at a distance of 2.1667 meters. I hope you guys have learned something from this, and I'll see you inshallah in the exam. Assalamu.